The two forces of gravity and electromagnetism seem at first sight to be sufficient to explain everything we see or feel in our everyday world. But once we look inside the atom, it is immediately obvious that other forces must be at work in the universe.
By the mid-1930s, we knew that atoms are composed of electrons orbiting a nucleus of protons and neutrons. But there's a problem with this model because protons are positively charged. And so when they're close together, the electromagnetic repulsion should blow the nucleus apart. And that's not what happens, of course. There must be another force many times stronger than electromagnetism that glues the nucleus together. And that force is called the strong force.
The strong force is not only responsible for holding the nuclei of atoms together, and without that, every atom in the universe would just spontaneously explode. But it's also, and this is quite interesting, responsible for 98% of nuclear mass. That means 98% of my mass, your mass, the mass of the Sun, the mass of the Earth. And we don't quite know exactly how the strong force generates that mass. And so we want to study that in more detail.
The discovery of the strong force was a giant leap forward in our understanding of nature.